Hi everyone. We're going to do a quick video on using E-clips to retain different items such as like pulleys and spools and retaining shafts within like the structure of your robot. So we're going to go over how and why we use those. So if you look here, this is an E-clip. They're made out of spring steel, and we use those to snap onto a shaft like this, and that keeps whatever's on the shaft from being able to slide off. The thing we need to do though is create a groove in the shaft that will accept that, so that when it snaps in, it too will be retained on the shaft. So the way we do that is we actually do that on the lathe. So there is a machining process or machining step, and sometimes that deters students from maybe using the E-clips because they hear the word machine a groove into something and they think that it's this big elaborate machining process, where it is actually quite easy to do. And how we do that is we use a tool for the lathe. You all should have probably had some experience with the lathe by now, with IAP and such. But this tool here is specific to the E-clip because the tip, and I'll move it over here to the zoom, you can see the tip of it is ground to the same width as the E-clip, so that when we put the groove in the shaft, that's the width of the tool that we have here. It'll accept the E-clip and the E-clip will be retained. So we're going to step over to the lathe and we'll show you how quick and easy that process actually is. All right, so here we are at the lathe, and we're going to put our grooves in now. Like you saw earlier in the video, I put 2 marks on my shaft so that I have a location for my grooves. So it's easy as I put this into the lathe, I lock it in place, I turn the lathe on, and now using the carriage I move back and forth to locate where I want my groove. Now I'm going to slowly bring my tool in until I just touch off. So what we're doing is we're establishing the major diameter of our material. And there I've touched off. So I want to add that to the digital readout. So we're in the x-axis. I highlight that. I tell the machine I want my diameter to read 0.25. That's a 1/4 inch material. Now the industry standard is machining the minor diameter down to 0.212. And we're going to do that. We're going to bring the tool in very slow until we get to the 212 on the digital readout. And that will be our minor diameter. And there we are. Alright, so I want to do this on the other end, so I'm going to stop the machine, clear the material off, flip it, turn the machine back on, locate my black mark, and again bring my tool in really slow. But now that I've already established the major diameter of the material on the digital readout, I don't need to reinstall that. That's going to be there until I change it. I'm going to bring it in. Again, everything's deliberate with these little tools. And then machine down to 0.212, the minor diameter. And there we are. So now we have the 2 grooves in our shaft. Oops. 2 grooves in our shaft. Now let's go back to the bench and see how that worked out. Alright, so back from the lathe now, and you can see the 2 grooves that we've put into the shaft. And what those 2 grooves are for is to retain our wheel or our spool onto that shaft. So you can see that that groove, we take the E-clip and we line it up with the groove that we've made, and then we snap it on. And sometimes you can do it with your fingers, like that. You can see how that snaps, and see how those three little ears that are on the ID of this E-clip, how they snap right in there. They snap in because this is actually made from spring steel, and so it has a little bit of give, but it always wants to go back where it came from. So that's that little snap. So now you can see that there's no way that I can pull this spool off from the other side. So if we did that on this end also, we would have a spool that cannot come off the shaft. And if needed, you can actually put the grooves up closer to the sidewall of this particular item, and limit the amount of slide that this has, so that locating maybe this roller or this spool or whatever this is imitating doesn't have as much play, but still has the ability to rotate. So that's kind of cool. So let's take a little closer look also at some of the ways we can use these E-clips. If you look here, I made this little device that has some scenarios built into it. For instance, my thumb over here on this side, you can see that I have a spool. So maybe this is to wind up a string in your device or something. And you can see that I have the ball bearings on that one. You can see the ball bearings right here. And then you can see the E-clips that are in the shaft. This shaft resembles the one that we did on the lathe there in that video. The E-clips are on each end of the shaft, on each outside portion of the bearing, the flange side of the bearing, so that it captures everything. The shaft can't go but a little bit side to side. And we used a flat on the shaft and a set screw to tie that together so that the spool is located in the shaft. The next one over here is an idler, right? You can see that I've used 4 E-clips in this case. I've used 2 internally here on this 5/16 diameter shaft. That's something I haven't talked about yet. The 2 sides, or the 2 main sizes of shaft that we have, are 5/16 and 1/4. Therefore, the E-clips are specific to that diameter also. So here I made just an idler, and I used an E-clip on each side of it so that this idler can spin, but I've also maintained its position on the shaft at some point, that whatever was desirable. And again, just like the ball bearing one, the bushings are in this plate. I have the E-clip up against that on both sides that limits the ability of the shaft to be able to come out. And same thing as we go forward. This one here, though, I put the flange of the bushings on the inside of my bracket, and I put the E-clips on the inside so that this has very little play end to end. And I have my pinned gear. You can see the pinhole right there. And I have a pin that pins that gear. And it's pretty simple setup, and it's really kind of the way to go. And one of the advantages of using the E-clips is they come off so easy. If I wanted to remove this E-clip, there's a couple ways of doing it. I could put a screwdriver in right behind these little openings right here, or the pliers, and you just pry it off, and it comes right off. So that's the nice part of it. And now I could do whatever I wanted, change the geometry of my part, or replace the part, and then just put another E-clip right back in its place, and we're back where we want to be without too much disruption to the build. And this one here, this last one that has the gear on it, it's a little more complex, just for the fact that I have 2 diameters and a hex. So we have available to us some hex stock that this kind of mimics it, this part that I made right here. You can see that I have a 1/4 inch diameter here in the hex stock, and then another diameter here. Well, that's kind of what's going on in this position right here, is I have the hex stock that is acting as the driver for my gear. You can kind of see that a little bit in right there, right between the E-clip. You can see the hex. Well, the hex is inside the gear. Now, that's guaranteed not to slip. Then I turn that hex stock down to the 5/16 diameter to accommodate my 5/16 E-clip. That maintains the positioning. Even though the hex it's going to rotationally keep it locked in place, I want to eliminate any possibility of this gear being able to move along that hex. And then I turn the rest of the diameter of my shaft down to quarter to go through the 1/4 inch bushing and then retain it externally here with the E-clips. So when you, if and when you hopefully choose the E-clips, referencing this video will help. And this display will be out with the rest of the build models that are out there. And hopefully that generates questions or maybe solves some problems that you might run into during your strategy and design. All right, so I hope that helps.